Mhm. Just wait a minute. If I'm going to open this one, how will it look like? Okay, no problem. Okay, so let's just start this. Uh, the next is reaction with ammonia. Reaction with ammonia. So for reaction with ammonia, if you are going to see, that means we are studying the carboxylic acid chemical properties. So you are going to react this carboxylic acid with ammonia NH3. So you know what will happen. Very simple. This is your base, right? And this is your acid. So base has a lone pair. Basically, what happens from this acid, H plus will release. H plus, when it will be in the form of H plus, this will be attacking and forms NH4 positive. Forms NH4 positive. Before that, this becomes CH3 C double O negative because H plus released, and here it becomes NH4 positive. Basically, NH3 will attack H plus and forms ammonium ion, and this is the intermediate that you will get. This is the intermediate that you will get. After this, if you are going to heat this, what will happen? H2O will be eliminated. That means dehydration will take place. So you can easily understand H2 and O. If you are going to remove, it becomes CH3CO NH2. This compound has a name that is known as ammonium cyanate. Ammonium cyanate. And this has a name aceta. If you are going for common name, it will be acetamide, or you can call it ethanamide. You can call it ethanamide. That is your IUPAC name. So I hope it's clear. So basically, carboxylic acid will give H plus, and that H plus will react with ammonia to form NH4 positive ammonium ion, and then this carboxylate anion will be in bond with NH4 positive. The bond will be purely ionic. Both of you getting my point?
Yes.
Right. Are you comfortable with this? Since I'm looking at the laptop, half of the slide only showing.
Yes, it's okay.
Okay. Let me know when you are done with this, and you can do this question. This, you know, that benzoic acid, if you are going to react with this. And also, one thing that you need to take care is that this is a reversible reaction. Okay. So you will get something after that. You are going to heat it, then you will get. Done both of you with the first reaction.
Yes.
Okay. Now see, again this will release H plus and this H plus will be attacked by this lone pair and forms NH4 positive. And this carboxylate anion, you can see it will be double O negative, then comes into play NH4 positive. After this, again you are going to heat it. So water molecule you are going to remove. You can see H2 and O when you are going to remove, it forms amide, C double bond O NH2. This is the same thing, C double bond O NH2. So this has a name that is equal to ammonium benzoate. This is your ammonium cyanate. Oh, wait a minute. Cyanate, how can I write? Acetate, this is, sorry. S means two carbon. And this is your ammonium benzoate. I hope this is clear to both of you. And this is your benzamide. Yeah, let me know when you are done with this.
Yeah, done.
Okay. Come to the next. Next reaction is also very easy. You can easily do this. You can see this is your benzene 1 comma 2 dioic acid. This is your C double OH, C double OH. Now again you are going to react this NH3 with NH3 and the same reaction will be your reversible. So what will happen? Very simple. This H plus will be eliminated, this H plus will be eliminated. So it becomes like this. C double O negative, C double O negative. Now there is 2 moles of NH3 that will come into play and becomes NH4 positive and NH4 positive. This has a name that is ammonium phthalate. Ammonium phthalate. Ammonium phthalate. After this, if you are going to heat it, then you know what will happen. 2 molecules of water will be eliminated. If one C double O negative NH4 positive is there, one molecule of water will be eliminated. And since here 2, so it will be 2 molecules of water you are going to remove. So if you are going to remove 2 molecules of water, it becomes amide here as well as here. Now after this, again, if you are going to heat it strongly, very strong heating, very strong heating. So you know what will happen? NH3 will be eliminated. NH3 will be eliminated. So let's say NH2 from here and H from here. So what you will get at the end will be this. There is a benzene and then there is a C double bond O and NH2 from here. That means C double bond O here and H from here. So here left only NH and this will be bonding like this and this has a name, phthalimide. This compound will be again phthalimide. Again you will see in amines chapter. So I think these reactions are very easy, right? Let me know when you are done with this. Now, the next chemical reaction we are going to see is reaction involving COOH group. Reactions involving COOH group. So very simple it is if you are going to see COOH group. So the first reaction involved is your reduction. That means you are going to reduce this. What do we say? We are going to reduce carboxylic acid. So how we are going to reduce? So very simple, you are going to use a very strong reducing agent, like either you can use LiAlH4 in the presence of ether, or either you can use B2H6 as well, diborane, followed by hydrolysis. So what will happen? Basically, this carboxylic acid will be directly converted into this carboxylic acid directly converted into alcohol alcohol. So you can see this was like this, RC double bond OH. And if you're going to use this reagent, this bond will be broken, hydrogen will be added here, hydrogen will be added here, hydrogen will be added here, hydrogen will be added here. So this part, if you're going to focus, it will become RCH2OH and H2 will be eliminated like this. So it will be directly converted into carboxylic acid. The next reaction that I'm going to talk about, you have studied this in class 11th as well, decarboxylation. Decarboxylation. What is decarboxylation? So basically elimination of Na2CO3 will take place. Now see what happens when you are going to use not carboxylic acid but carboxylic acid salt. That means in carboxylic acid you have seen C double OH. If that H is replaced by a metal, that is called carboxylic acid salt. And you are going to treat this with soda lime, NaOH and CaO, mixture of NaOH and CaO and heat. So what will happen? Very simple. This whole quantity will be eliminated and it becomes Na2CO3. This is your byproduct. This is your byproduct. And this R will be connected with H directly. Hydrocarbon it will give. What it will give? Hydrocarbon. The soda lime is very important. Their question has been asked, soda lime, what is soda lime? So basically, soda lime is mixture of NaOH and CaO in the ratio 3 is to 1. In the ratio 3 is to 1. Very important it is. The ratio is very important. Let me know when you are done with this. Very good. The next chemical reaction, the last chemical reaction is your substitution reactions in the hydrocarbon part. In the hydrocarbon part, that means simply, that means COH will not be involved, only the R group, alkyl group will be involved. And here comes the first, that is very important. And that is your halogenation, and it is a name reaction. Halogenation, and it is a name reaction. So basically, this reaction is applicable when you have an alpha hydrogen of carboxylic acid. So basically, I'm going to write a point about this. Write with me. Just wait a minute. Yes, write it. Carboxylic acid having an alpha hydrogen. Just wait a minute. Let me write it. R. Halogenated. This is your halogenated. Carboxylic acids having an alpha hydrogen. Halogenated at the alpha position. On treatment with chlorine or bromine, chlorine or bromine, in the presence of a small amount of red phosphorus to give alpha halo carboxylic acids. So very simple it is. With respect to carboxylic acid group, carbonyl group, you are going to have an alpha carbon. If that alpha carbon has an hydrogen that is known as alpha hydrogen, that will be replaced by this halogen, and that is, this reaction is known as, basically, this reaction is known as Hell-Volhard Jelinski reaction. Hell-Volhard Jelinski reaction. I'll show you the reaction as well. First, write it. Let me know when you're done with this. Both of you done with this?
Done, sir.
Okay. So the reaction, if you are going to see, I'm going to take carboxylic acid. This is your carboxylic acid, RCH2, C double OH. And then you are going to react this with X2 in the presence of red phosphorus. And the second one followed by hydrolysis. Very simple it is. This is your functional group, right? So if this is your functional group, this carbon will be alpha carbon. This carbon will be alpha carbon. And now this alpha carbon has two alpha hydrogens. So one of the alpha hydrogen will be replaced by this X. And X is equal to chlorine bromine. And we can call it alpha halo carboxylic acid. Very simple it is. Are you done with this? The next one is your ring substitution. And this reaction, you can easily do it. If I'm going to take this benzoic acid and going to react with concentrated concentrated HNO3 in the presence of concentrated H2SO4. So you know that this reagent will be giving you an electrophile, which is NO2 plus. Now, whenever you have an electrophile, you are going to look at the group which is connected. You are going to look at the group which is connected to the benzene ring. So as you can see, C double OH, which has a tendency of -m, that means it will withdraw or decrease the electron density in the benzene ring. There will be either positive charge. The positive charge will be at ortho and para. And NO2 plus is already having is an electrophile, so it will attack only at meta. So this is the product that you will get. NO2 will be at meta, and this will be as it is. So its name will be M-nitrobenzene, meta-nitrobenzene, benzoic acid, nitrobenzoic acid. Let me know when you are done with this. Okay, very good. So the chapter is completed here. So you will get assignment as well, but I'm going to give you some questions from NCRT. So you need to submit this. All the in-text question, either solved or unsolved, in-text question, and write it clearly. In-text question, solved and unsolved. Is that clear? So we are going to start this new chapter. That is your alcohols, phenols, and ethers. Okay, so first we will study about alcohols, then phenols and ethers, but we are going to classify this alcohol and phenol together. Okay, so very simple. The way we did the first chapter, classification. So I think you are aware of this classification. First, the classification is about on the basis of number of on the basis of number of OH group, hydroxy group. Just wait a minute, please. Okay, so I can write here on the basis of number of hydroxyl group, that means OH group. So you know that very simple it is. If it is only one OH, that is your monohydric. If you have two OH, that is your dihydric. If you have three OH, that is your trihydric. This is your dihydric, and this is your trihydric, and so on. We can classify in that way as well, right? Mono, di, tri, tetra, and so on. So this is the first classification that we did. The next classification we can go for compounds containing CsP3OH. That means very simple. To the carbon to which this is connected, OH is connected, should be sp3 hybridized. sp3 hybridized. So here comes the degree of alcohol. It is same as halogen, haloalkane, haloarine we studied. So how do we calculated the degree of haloalkane? Basically halogens. We need to calculate the degree of that carbon to which X is connected. In the same way, let's say if you have this CH3CH2OH. So if you want to calculate the degree of this alcohol, first you need to calculate the degree of this carbon. Okay, so you know that this has a degree, that is 1 degree. So this is also having 1 degree alcohol or primary alcohol. Are you getting my point, both of you?
Yes.
Please do respond. In the same way, if you are going for this CH3 and OH is there. So in order to calculate the degree of this alcohol, you need to calculate the degree of this CH3. Very simple. So you know that the number, how to calculate the degree of carbon. Very simple it is. You already know that it is connected with 2 carbons. So this is 2 degrees. So this is also 2 degree alcohol, or known as secondary alcohol. In the same way, we can go for tertiary as well, CH3COH, and then comes your CH3, and then comes your CH3. So very simple it is. This has a degree. This will have a degree, tertiary, 3 degree or tertiary. So I hope this is very simple and you got all of it, right? Let me know when you are done with this. Are you done with this?
Okay.
Okay. Now the next, what do we say? The next classification is your allylic alcohols. You have heard this term in allylic halogens, you can say allylic halide. So allylic alcohols. That means very simple, allylic alcohols. Very simple it is. I'm going to explain. See, it's the part of this previous ones, compounds containing sp3 carbon. Okay, I'm gonna show you. Very simple it is. First of all, there will be double bond, and then this, and then CH2, and then X. Why I wrote it like this? So basically, it's very simple. To the carbon to which this X is connected should be sp3, and adjacent to this carbon should be doubly bonded or sp2. Adjacent to this carbon should be doubly bonded. So this is known as allylic halide I wrote. Basically, here it will be, since alcohol we are studying, so there will be OH. Allylic alcohol it is. Are you getting my point? To the carbon OH is connected should be sp3, and adjacent to this sp3 carbon should be sp2. And in the same way, you can classify this as primary, secondary, tertiary. So this is your primary. If you want to classify on the basis of degree, you can do this. In the same way, if you are going for, can anyone tell me whether this is allylic, yes or no? This is allylic, yes or no? Is this allylic? Not audible. Any one of you? So very simple. If you are going to check, this is sp3 and this is doubly bonded. So this is also allylic, but if you are going to check the degree, this will be secondary. Yes or no? Because this carbon is connected with two carbon, that's why it is secondary. In the same way, this is your sp3, and your this is your sp2 doubly bonded, and this is tertiary. So I think it's clear to both of you. Both of you done with this?
Yes, sir.
Then comes your benzylic alcohol. It is the same part of this sp3oh, csp3oh. So for benzylic alcohols, if we are going, so I think it's very simple. There will be benzene, and you know that this is doubly bonded CH2OH. So you can see, to the carbon it is connected, to the carbon it is connected is sp3, and the adjacent carbon is sp2. So this is benzylic alcohol, and you can classify this as primary. In the same way, if you have another benzylic alcohol like this CHOH, and then CH3 is here, this is also benzylic alcohol, but this is your secondary. In the same way, for tertiary you can write. Are you getting my point? So
Yes.
basically, allylic benzylic alcohols may be primary, secondary, and tertiary. Are you done with this?
Yes.
Okay. Now the next comes is your next classification, compounds containing CsP2OH. That means to the carbon to which OH is connected is sp2 hybridized or doubly bonded or doubly bonded. Okay, so very simple it is. I'm gonna show you. So let's say, and this is called vinylic alcohol. This is called vinylic alcohol, like CH2 double bond CHOH. So if this OH is directly connected on the sp2 carbon, that is called vinylic. Let's say this is the scenario. This is also your vinylic alcohol because it is directly connected to the sp2 carbon. In the same way, you can go for phenol, you can make that is your, it is directly connected to doubly bonded OH. So this will be the scenario. Let me know when you are done with this.
Done.
Both of you done with this. Very good. So I think you can classify primary, secondary, tertiary. Only you need to tell me primary, secondary, tertiary. I'm going to write the compounds. You can directly tell me if you know. No need to write. Because this concepts you already practiced in class 11. The first one is, what do you think? Let me know when you're done with this. So see if I'm going to tell you about this. This is connected with this carbon and this carbon is having 1 degree. So this is primary alcohol. Yes or no? This carbon we need to calculate connected with 1 degree. So this is also 1 degree alcohol or primary alcohol. So this OH is connected with this carbon and this carbon is connected with two carbons. So 2 degrees. So this alcohol is secondary alcohol. If you are going for this OH, calculate this. pH means benzene. pH means benzene. That means one carbon, 1 degree. So this is also primary. And if you are going for this alcohol, this carbon is connected with two carbons. So this is 2 degree carbon. So this is also secondary or 2 degree alcohol. Are you getting my point? Both of you.
Yes.
Can I change the slide?
Yes.
Okay. Next is basically ether. And ether's general formula you should know. ROR. This is your ether's general formula. Now, There can be two types of ether. One is symmetrical and another is asymmetrical. Or we can write unsymmetrical, NCERT term, unsymmetrical. What is symmetrical? So basically, both the alkyl group same, alkyl group. If alkyl group is same, then it is symmetrical. Alkyl group different, then it is asymmetrical. Let's take an example. If it is CH3O, CH3, then you can look at the alkyl group, this and this same. So it is an it is a symmetrical ether. And if you have something like this, the alkyl group different, one side two carbon and one side one carbon, like this, you can see methyl is there, ethyl is there. In this case, this is your unsymmetrical, this is your symmetrical. So I hope it's clear to both of you, right?
Yes.
Okay. Let me know when you are done with this. Are you done with this?
Yes, sir.
Okay, let's go on nomenclature. So directly I'm going to give you some question. Let's see whether you are able to solve it or not. Any answer? Both of you done with this? Austin, am I audible? Any answer for the first one? Okay, okay. Hmm. Methanol, ethanol, propane, 2-ol, 2-methyl, propane, 2-ol, propane, 1,2,3 triol. Very good. Humam, what about you?
Yes, I also did.
Okay. Is there any doubt in that,
No, Sunny.
Humam? Okay. So do this as well. Are you done with this, both of you? See, I'm going to explain. This is very easy. This is your cyclohexanol. Cyclohexane. So cyclohexane one all, so it becomes cyclohexanol. This is your 1,2. So this is your methyl. So we can write 2-methyl cyclopentanol. Cyclopentanol. This is your 1,2. So this will have a name 2-methyl phenol. Now you can see 1, 2, 3. So you can write 3-methyl phenol. 3-methyl phenol. Or you can also write meta M-methyl phenol. This is your phenol. And this is your benzene 1, 2 dioic acid. Diol. Benzene 1, 2 diol. So we